which of the following is an integer? And then we have a 3-in-1 question where they give us three expressions, three factorial expressions. And so what are we looking for? We're looking for a case, because factorials are usually really divisibility questions. And so we're looking for a case where our numerator, the factorials in our numerator, fully cancel out the values in our denominator. And so that will just leave us with an integer. And so let's see which ones do that. So statement 1, it's 12 factorial over 6 factorial. And so that's 12 times 11 times 10 times 9, all the way down to 3 times 2 times 1, all over 6 times 5 times 4 times 3 times 2 times 1. And so our 654, 321 should cancel out fully with the 654, 321 in our denominator. That just leaves us with 12 times 11 times 10 times 9 times 8 times 7. What we're left with, which I don't know what that is, but I know it is an integer. So statement 1 is true, and we can eliminate B and C. Statement 2 says 12 factorial over 8 factorial. So this is the same as above. And so if you see the pattern in the first one, you should quickly see the same pattern here in the second one. And so, except in the first one, it was the 6 through the 1 that canceled out. Here it should be the 8 through the 1 cancels out. So we're just left with 12 times 11 times 10 times 9. I don't know what that is, but I know it is an integer. And so A can be eliminated. Then statement 3 says 12 factorial over 7 times 5, 7 factorial times 5 factorial. So I guess they're trying to get you to say the denominator is equal to 12 factorial. That is not true. And so up top, we have the same thing as before. We got 12 all the way down to 1. Then in our denominator, though, we got 7 factorial. So 7 times 6 times 5 times 4 times 3 times 2 times 1. So this will cancel out with the 7 through 1 up top. And then we got left over 5 times 4 times 3 times 2 times 1. So even though we used all those values here, we might be able to still cancel out some things. For example, 5 in the 10 leaves you with just a 2 up top. The 4 in the 8 leaves you with a 2 up top. The 3 and the 9 leaves you with just a 3 up top. And then this 2 here, this 12, leaves you with a 6 up top. And so we are able to fully cancel out our denominator, leaving us with just 6 times 11 times 2 times 3 times 2. And just as before, I do not know what that value is, but it is some integer. E.